Hey everybody, what's good? JB here, back with CyberInsight. Day 7 of TryHackMe Advent of Cyber. Pretty exciting. It's kind of funny. Today's room is going to be dealing with analyzing malicious documents and using a tool called CyberChef. Somehow we just kind of lucked into it yesterday when we were going through the previous room. I think it was on email analysis. I pulled up CyberChef to decode some Base64 data. So I guess a little bit of a preview without knowing that that was going to be the case. So yeah, we're going to hop into this. If you have any questions or comments, throw those in the chat as you always do. Appreciate it if you smash the like button, subscribe to the channel, all that other good stuff. And yeah, we're going to dive into this. So let's see what's going on. In the previous task, we learned that McSkitty was indeed a victim of a spear phishing campaign that also contained a suspicious looking document, the Division of Labor Load Share Plan .doc. McSkitty accidentally opened the document, and it's still unknown what this document did in the background. McSkitty has called on the in-house expert Forensic McBlue to examine the malicious document and find the domains it redirects to. Malicious documents may contain a suspicious command to get executed when opened and embed a malware as a dropper, malware installer component, or may have some C2 domains to connect back to. So what are we going to look at today? How to use CyberChef? What are the capabilities of CyberChef? What it is? How to leverage CyberChef to analyze a malicious document, and how to deobfuscate, filter, and parse through the data as we move through different phases of analysis of the document within CyberChef. So for the lab deployment for this, just got to hit the start machine up here to spin up the machine that we're going to be using that has the malicious document and CyberChef on it. If you don't see that pop up once that's done, you can hit the show split view, and it should bring it up, and you're going to end up getting a nice desktop that looks like this. So let's see. So CyberChef Overview. It's a web-based application used to slice, dice, encode, decode, parse, and analyze data or files. So the layout is explained here. An offline version of CyberChef is bookmarked in the Firefox on the machine attached to this task. So we really got a few different things. We've got the input over here, which is where we could either copy and paste data into that, which is what I did yesterday with the Base64 encoded data, or we could drag a file and drop that in here. And then at the bottom here is the output. And the output is going to be derived from whatever little operations that we have over here on the left-hand side that we drag and drop into this recipe. So you could just do one thing, which is what I did yesterday, where I dragged the from Base64, put it in here, and it took the data that was in box 1, it de-encoded it from Base64, and the output was seen down here in box number 4. If you have the auto bake selection here, you don't have to keep hitting the button at the bottom. So pretty much every time you add a new step into the recipe, it will just automatically do that, or any type of changes to the attributes within the recipe. As far as what the recipe is, really, it's just all these different options that we have over here of things that we can do with the data, whether it's encoding it, decoding it, changing the format, finding and replacing different types of data. You can do all of that and do it kind of in sequential steps. And you're going to see, I think that's what we're going to be doing here in this particular room. So let's look at using the functions as recipes to analyze the malicious document. And they kind of just walk through everything that we need to do here. So first thing we're going to do is we're going to add this document into CyberChef. And then we are going to extract the strings from that. So let's go ahead and just pop this open. Yeah, and they have it here bookmarked, so that makes it easy. Remember, this is an offline version of this, so it isn't actually going out to the internet. Okay. And so here, all we're going to do is we're going to add a file as input. We could drag and drop it, but I don't want to minimize the screen. I want to make it so you can see this as good as possible. So we have auto bake selected here. And then I think the first thing that we were going to do was they wanted us to look at the strings. So in the search bar over here, You can type in and search for different operators and operations you can do. Just to give you a quick little look through here of different stuff. Data format, you can change it to different things, binary, hex, Base64, whole bunch of different encoding and decoding techniques. Encryption, if you have the keys, then you can go ahead and encrypt or decrypt data in different ways. Let's see what else is kind of, we can defang IP addresses, defang URLs. Pretty much that makes it so that if you won't actually like click on it and it actually will load it. Normally that involves putting brackets around like the periods. We can change the languages. We can compress. So if it's a gzip or something like that and we want to unzip it, we could use this here. Hashing. Again, different hashing algorithms. So just a whole bunch of different options there to do stuff. And if you have a hard time finding whatever you think should be there, then you can just use the bar, the search bar over here. And we're going to take this strings and we're just going to drag it over here. But let's go see first off, before we do anything with that, what they're saying about this. So strings are ASCII and Unicode printable sequences of characters within a file. We are interested in strings embedded in the file that could lead us to suspicious domains. So we're looking for URLs. Use the strings function on the left panel to extract the strings by dragging it to panel 3 and selecting all printable characters as shown. So we already did that. Match all printable characters. Let's see if we can kind of move this up a little bit since we already know that file's in there. And so we can kind of see that we do have a whole bunch of strings that came out here. And then a whole bunch of stuff that kind of looks obfuscated, so we don't really know what that is yet. And a lot of times you'll find that somebody doing something malicious will actually obfuscate the data, so that would make perfect sense to see something like that. If we examine the result, we can see some random strings of different lengths and obfuscated strings. Narrow down the search to show the strings with a larger length. Keep increasing the minimum length until you remove all the noise and are only left with meaningful strings. So we're just going to kind of keep making this the minimum length larger and larger and larger to get rid of the smaller strings. So like these would be smaller strings. So let's just, if we go 100, and we see at that point, like that is one string there that's all together. And then the rest of this here. So let's go 200. Okay, and remember, because I have auto bake, I don't need to hit enter with this in any way. So we're still kind of looking at the same stuff. We just want to get to that stuff that looks obfuscated. So I think they had it as 258. Yes, and then 258 leaves us with all of this here. Okay. Now it looks like kind of like junk characters in here. So like if we were to find a way to like remove this kind of bracket with underscore, then we might have a better idea of what we're actually looking at. Because you see it looks like CMD, 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 /C, MSG, USER, so like username, right? So we'll probably have to get rid of those things that's kind of taking up space there. So let's see what they say. Yeah, okay. Remove a pattern. Attackers often add random characters to obfuscate the actual value. If we examine, we can find some repeated characters. So kind of, like I said, the brackets and the underscore. So as these characters are common in different places, we can use regular expressions, or regex, within the find and replace function to find and remove these repeated characters. To use regex, we'll put characters within the square brackets and use the \/ to escape characters. In this case, the final regex for getting rid of this bracket underscore bracket is going to be this sequence right here. So bracket backslash bracket backslash bracket bracket n, and then the underscore, then a bracket to close it out. So here the backslash n represents the line feed as shown below. All right, so we can just go ahead and copy this over, and we're using the find and replace operation. So let's go find and replace. And remember, we're just going to drag it. You want to make sure that you drop it beneath the one that is up above, because it is going to be read in sequential order. And we're going to take this, copy that, and we want to go find. I'm going to paste that, and we aren't going to replace it with anything. So now you see that we did that. It removed all of that, and this looks a lot better. So it's command, 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 and then a username. Try to open a file. Looks like something with PowerShell, and then a whole bunch of what looks to be Base64 encoded data. So the next thing we might do with that, if we want to get rid of all of this up above and just focus on the Base64 data, a few different things. So we can do something to completely remove this data here and keep kind of the recipe going the way it is, or we could just copy and paste the text that we wanted to, remove all the recipes, take this Base64 encoded stuff and copy that into the input area and kind of start over. But I think they want us to kind of like keep adding steps. So let's see. Drop bytes. To get access to the Base64 string. Well, actually, let me read this part here. It's evident from the results that we're dealing with a PowerShell script. And it's using Base64 encoded string to hide the actual code. So to get access to the Base64 string, we need to remove the extra bytes from the top. So we're going to use the drop bytes function to kind of get rid of these top two lines. I'm going to drop bytes. Okay, and let's scroll down, and here we can just kind of just make that length go. Pretty much every time I hit this, it's deleting one of the characters off of there. So we can just go ahead and get there. I think it was 128 was what I saw on the screenshot, but we'll see. Maybe it was 122. 124. Okay. So then at that point, we have this Base64 data. And so we can go from Base64. And we can take this. And we're going to drop this down at the bottom. There we go. And now we see this whole set variable something. So we can see that it's a whole bunch of PowerShell commands, but there's a whole bunch of kind of extra characters that look like they're added in here. So like periods, maybe these parentheses, these apostrophes. Let's see what they want us to do next. So we already did the decode Base64. And that kind of leaves us with that. So decode UTF-16. So Base64 decoded results clearly indicate a PowerShell script. Yep. Which seems like an interesting finding. In general, PowerShell scripts use the Unicode UTF-16LE encoding by default. We'll use the decode text function to decode the results. Okay. So that was more like a formatting thing as far as what we were looking there. So we can do that and go decode text, and it was the UTF-16LE. Let's see. That's good to know, because I would not know the that PowerShell was in that particular format. So we're going to go all the way down, drop it below that, decode text, and we want to go UTF-16LE. Okay, so that looks like better formatting here a little bit, makes more sense. We still have all those extra characters that I was mentioning, though, that kind of jumbles this up. So let's see what they want. Find and remove common patterns. Forensic Blue observed various repeat characters, so like the apostrophe, parentheses, plus, more apostrophes, kind of all of these within the output, which makes the result a bit messy. Let's use regex again, so we're going to use the same operation we did before, the find and replace, to remove the characters as shown below. And so the final regex will be this. Remember that you just, whatever we're removing, it needed to be in brackets. Okay, so we can go like that. Let's find and replace. I'm going to drop that at the bottom. I'm going to copy this over. We're just going to get rid of those. We don't need to put a replace there because we're just removing it. Okay, so now we're looking at something here that looks a little bit cleaner. What do we see kind of going on here? We do see google.com, secretsanta.thm, see like a flag in here. Bandit Yeti.thm files index. But what's kind of weird with that is like this B2H underscore S colon B2H underscore S. So that kind of looks like maybe the B2H underscore is like for HTTP. So maybe they're kind of like obfuscating it that way. Let's see. If we examine the output, we'll find various domains and some weird letters. Okay, yeah. Before each domain reference, replace function is also found, so we can replace that with HTTP. Cool. So let's go, we're gonna replace, no, not alpha that, I want find and replace. There we go. Okay, and we can just take this like this. Is it B2H is what we're kind of looking at? I think that's what they were talking about replacing. No, the bracket too. Okay. So let's go this. And we can replace that with HTTP. Okay. So this looks a little bit better now. HTTPS. Got these like @ signs in between these different URLs, which is kind of weird. Extract URLs. So let's see. Let's say the results clearly show some domains, which is what we expected to find. We'll use the extract URLs function to extract the URLs from the results, because that's really what we're hunting for here. Extract URLs. I'm going to drag that to the bottom. Okay. I'll split URLs with @ sign. So the result shows each domain followed by the @ character, which can be removed using the split function as shown below. I'll just go split. Okay, so then that kind of does that and hits enter to separate those so it's per line. So that looks pretty good. Let's see what they have next. Defang the URL. Great, we have finally extracted the URLs from the malicious document. It looks like the document was indeed malicious and was downloading a malicious program from a suspicious domain. Before passing these domains to the SOC team for analysis, it's recommended to defang them to avoid accidental clicks. Defanging URLs makes them unclickable. So we're just going to go defang. Defang URL and drag that down below. And there, so it removed the HTTPS and then it put some brackets around some different points here. Cool thing with this, if there's certain things within the recipe that you don't want it to act on anymore, you can just hit the pause button. So you could do those at any point here. So, you know, if we wanted that part of the recipe to take action or not, we can just hit that. But useful to know. So let's answer these questions. What version of CyberChef is found in the attached VM? So I think we saw this right up here. So it's 9.49.0. Okay, how many recipes were used to extract URLs from the malicious doc? There was a lot. 1, 2, 3, 4. I think it was, might even just be easier to count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the string. So let's go 10. We found a URL that was downloading a suspicious file. What is the name of that malware? Looks like mysterygift.exe. Let's see. Okay. What is the last defanged URL of the Bandit Yeti domain found in the last step? So I had that paused, but let's unpause it. And so they want this Bandit Yeti URL. We'll copy that. Nice to see Bandit Yeti's using a CDN. Nice little content delivery network, pretty sweet. All right, at that, what is the ticket found in one of the domains? It was the mystery flag. Golden ticket. Or THM, not the THM mystery flag. All right, so that was it. That is everything for a little nice introduction to CyberChef. Pretty cool. Lots of useful stuff with this. If you have any other questions or whatever, throw those in the comments section. Appreciate you checking out the video. And yeah, I'll catch you tomorrow with day 8. All right, take care.